Welcome to the Explainer. So today, we're literally putting on our senior examiner hats to break down exactly what makes an A-star answer for the OCR hazardous earth specification. We're zeroing in on section 4.b. That's the part evaluating how earthquake impacts hit people living in countries at totally different stages of economic development. We've got a really fantastic deep dive comparison lined up for you, looking at an advanced economy, Japan, and a low-income developing country, Nepal. Let's get right into it. So here is the exact exam prompt we're tackling today. How do earthquake impacts vary by economic development? Now listen, if you want to secure those absolute top marks, just listing facts isn't going to cut it. I mean, anyone can memorize the death toll, right? What we really need to see here is a deep, evaluative comparison that gets right down to the root of a country's vulnerability and its resilience. Okay, so here's our examiner's rubric to guide us through. 1. The A-star exam question. 2. Tectonics and human geography. 3. Assessing the social impacts. 4. Assessing the environmental impacts. And 5. The examiner's final verdict. Sticking to these themes is going to force that direct comparison, and trust me, that guarantees maximum marks.
All right, moving into section 2, tectonics and human geography, laying the baseline. Because before we can even begin to assess the impacts of an earthquake, we've got to understand the actual ground we're standing on.
Okay, let's dive into this tectonic comparison. Japan's geography puts it right on top of one of the absolute most complex plate boundaries on the planet. It's a subduction zone, where the Pacific, Philippine, and Eurasian plates are all crashing together. Specifically, you've got the Pacific plate subducting right beneath the Okhotsk plate at the Japan Trench. And that setup? It produces massive, just absolutely huge megathrust earthquakes, like that devastating magnitude 9.0 Tohoku quake we saw in 2011. Nepal, on the flip side, sits right on a continental collision zone. This is where the Indian plate is just relentlessly pushing north into the Eurasian plate, literally forcing the Himalayas up into the sky. And that specific boundary produces really shallow, highly destructive thrust earthquakes. Which begs the question, if these places are basically ticking time bombs, why on earth do people live there? Well, look at the stark contrast between these two populations. Japan explicitly accepts the risk in exchange for massive economic gain. I mean, their major cities are absolute global hubs for finance and tech. Plus, they have this immense confidence in their safety systems. We're talking incredibly strict building codes, massive tsunami defenses, and early warning systems that really lower the perceived risk. Now, jump over to Nepal. The population there often stays simply because of severe poverty and a lack of choice. A huge chunk of Nepal's people rely on farming on these really steep slopes, or they're packed into the crowded Kathmandu Valley. They literally just can't pack up and relocate. On top of that, communities stay in these super high-risk mountain zones because they rely heavily on the vital tourism income coming from trekking routes like Everest. Okay, Section 3, Social Impacts, Vulnerability. Remember, top-tier candidates don't just regurgitate numbers, they actually analyze these underlying vulnerabilities. Let's quickly review the baseline social metrics here. In Japan, you had 15,900 deaths and about 500,000 people left completely homeless. But the primary cause of harm, it was actually the resulting tsunami, not the ground shaking itself. Contrast that with Nepal, roughly 9,000 deaths but over 600,000 homes completely wiped out. And the main cause of harm there was the collapsing of unreinforced buildings. Now obviously these are staggering, horrific figures, but to get that A-star we really need to interrogate who exactly makes up these numbers. Now what's really interesting about this is this specific figure right here. 66%. Over 66% of the victims in the Japanese Tohoku earthquake were over the age of 60. This is the kind of stat that beautifully demonstrates an A-star understanding of Japan's specific demographic vulnerability. See, because Japan has a rapidly aging population, a huge number of its victims were simply unable to evacuate fast enough when those tsunami warnings finally hit. Let's pivot back over to Nepal for a second. Check out this unbelievable number, 10%. 10% of Nepal's entire population was displaced from the Kathmandu Valley alone. Guys, that's 2.8 million people forced out of their homes. Just think about that. This single stat really highlights the sheer, mind-boggling scale of social devastation in an LIDC, especially when the housing infrastructure just isn't built to take a magnitude 7.8 hit. So when we pull all these impacts together, we see this massive divide in how social vulnerabilities actually play out. In Japan, the impact was really about complex community disruption. The trauma there manifested as long-term PTSD and anxiety, especially for those elderly survivors. But then look at Nepal's inherent socioeconomic vulnerabilities. The poorest groups absolutely suffered the most. Because of incredibly weak healthcare and almost non-existent planning, lower caste individuals and women found themselves highly disadvantaged. And human trafficking actually spiked after the quake. On top of that, thousands of schools just pancaked, causing this massive disruption to education. And honestly, perhaps the most devastating part, the earthquake hit right in the middle of planting season. That triggered a massive food security crisis that forced over 1 million people to seek food assistance the very next year.
Moving along to Section 4, Environmental Impacts, Physical Fallout. Let's compare the incredibly massive physical and environmental shocks caused by these two seismic events.
And this brilliantly illustrates exactly what a top-tier student's research looks like in practice. These are real, handwritten notes comparing the Gorka and Tohoku statistics. But notice how they hit all the right evaluative marks. They aren't just dropping the magnitude numbers and moving on. They actually connect the depth of the earthquake's focus and the specific tectonic shifting to the really complex environmental consequences that came after. That's the level you want to be at. Let's dig into Japan's unprecedented environmental shocks. The sheer tectonic force here was literally off the charts. Northeastern Japan actually physically shifted by 2.4 meters. Think about that. The Earth's rotation even increased by 1.8 microseconds. But here's the really crucial part. Notice how Japan's highly advanced infrastructure paradoxically caused these super complex secondary hazards. The tsunami completely overwhelmed the Fukushima nuclear power plant, which released severe radioactive contamination. That radiation poisoned 11 different types of local vegetables and essentially made a massive area totally uninhabitable. Plus, industrial spills caused 220,000 barrels of oil to literally catch on fire, and 1.5 million tons of tsunami debris got dragged straight out into the Pacific Ocean. It was just a cascade of highly technological disasters. Now contrast that high-tech disaster with Nepal's physical topography changes. The intense shaking in Nepal triggered thousands of massive landslides that just obliterated 22,000 square kilometers of terrain. These landslides fundamentally rewrote the local environment. They blocked up river flows, which massively spiked the flood risk, and they entirely severed remote mountain villages from any hope of rescue for days. It even triggered that deadly avalanche at Everest Base Camp. And critically for their day-to-day survival, all those steep farming terraces just collapsed, which drastically worsened long-term soil erosion and essentially wiped out their agricultural foundation.
All right, Section 5, the examiner's verdict, synoptic evaluation. This right here is exactly what elevates your standard run-of-the-mill essay into a standout A-star answer.
So the crucial point really comes down to this. While advanced economies suffer unprecedented economic and highly complex environmental shocks, which, ironically, are often made way worse by their own advanced infrastructure, low-income developing countries suffer fundamentally systemic, deep-rooted social devastation. Grasping that cements the definitive contrast between Japan's built-in, yet occasionally flawed technological resilience and Nepal's absolutely devastating, compounding socioeconomic fragility. To wrap things up, I really want to leave you with a question that pushes for true, high-level synoptic thinking. How might climate change compound these exact tectonic vulnerabilities in the future? Really think about it. Consider how rising sea levels could actively threaten Japan's heavily engineered tsunami defenses, or how more extreme, unpredictable monsoon rainfall might drastically worsen the already severe landslide risks in Nepal's steep, shattered terrain. Exploring those messy intersections, that is where real A-star geographical analysis happens. Thanks so much for joining me for this explainer. I really hope this helps you craft the perfect analysis, and I'll catch you in the next one.